Hello and welcome. Today we're going to continue our discussion on factoring polynomials completely. First, we'll recall factoring trinomials with two variables. Remember, when you have two terms, you must use the diamond method. In the diamond method, we multiply the first coefficient, in this case it's a 1, by the last coefficient, which is a 12. That goes on top of your x. And on the bottom, we put the coefficient of the middle term, which would be a 7 in this case. Two numbers that multiply to 12 and add to 7 are positive 4 and positive 3. So I rewrite my 7uv with a positive 4uv and a positive 3uv. I still have the u squared on the front and the plus 12v squared on the end. Now I split this down the middle and take out the greatest common factor of the left, that is a u, leaving me with u plus 4v. And on the right, I factor out a positive 3v, leaving me with u plus 4v. I see u plus 4v repeated on both the left and the right, so I factor that out. And in my second parentheses, I'm left with u plus 3v. Before I move on, I'm going to look at both sets of parentheses to make sure that they are both prime. Looking here on the left, there is no GCF I can factor out. Neither is it the difference of squares, so this is prime. On the right, looking at those two terms, I do not see any GCF I can factor out, and again, neither is it the difference of squares, so this is also prime. So far as we have discussed, if there are only two terms and you are factoring, your only two options are to factor out a greatest common factor or to use the difference of squares. Since neither of these applied, these are both prime factors. On the right, my coefficient is a 1, multiplying by the coefficient of the last term, which is 5, gives me a positive 5 on top of my x. On the bottom of my x, I put the coefficient of the middle term, which is positive 6. My two numbers that add to 6 and multiply to 5 are positive 5 and positive 1. I rewrite my 6 in the middle as a positive 5xy plus 1xy. I still have the positive x squared on the front and the positive 5y on the end. Splitting this down the middle, I take out the x from the left, leaving me with x plus 5y. And on the right, I factor out a positive 1y, leaving me with x plus 5y. I see x plus 5y repeated, so I factor that out, leaving me with x plus y in the second parentheses. I'm going to look and make sure that each of these factors is prime before I move on. On the left, there is no greatest common factor, neither is it the difference of squares, so this factor on the left is prime. On the right, I see no greatest common factor between the two, and again, neither is it the difference of squares, so this factor is also prime. It cannot be factored any farther. Because both of these factors are prime, this is the final factored form of my original expression. Go ahead and try these next four on your own after pausing the video. From the first, you should have two prime factors of u plus 8v and u plus 3v. From the second, your two prime factors should be m plus 4n and m plus 3n. On the bottom left, your two prime factors should be x plus 4y and x plus 2y. And last, you should have u plus 2v and u plus 1v. I will show you one example of factoring when the leading coefficient is other than 1. We still proceed in the same exact manner. I multiply the leading coefficient by the coefficient of the last term. 3 times 4 is 12. I'm adding to the middle term, which is a negative 13. My two factors are going to be negative 12 and negative 1. So I rewrite the coefficient of my negative 13 as negative 12xy minus 1xy. My 3x squared still stays on the front, and my plus 4y squared still stays on the end. Splitting this down the middle, I take out a 3x from the left, leaving me with x minus 4y. On the right, I take out a negative y, leaving me with positive x minus 4y. Remember, our goal is always to make the first term of our parentheses positive, so since that negative 1xy is negative, I had to bring the negative out with my common factor. I now see x minus 4y repeated, so I factor out that common factor, leaving me with 3x minus y in the second parentheses. Before I move on, I'm going to double check that each of these factors is prime. X minus 4y is prime, as is 3x minus y. Since both my parentheses are prime, this is the factored form of my original polynomial. Go ahead and pause the video and try the next three on your own. From the first, you should have two prime factors of u minus 3v and 2u minus 1. On the bottom left, your two prime factors should be u plus 2v and 2u minus v. And last, you should have two prime factors of x plus 2y and 5x minus 2y. The last thing I'm going to discuss with you is what to do when your terms are not in the correct order. If you look back to the previous slide, notice that our polynomials start with a squared variable and end with a squared variable. In the middle, the variables both appear and each to the first power. So on this next slide, I need to start with a squared variable and end with a squared variable. And this term, with both of the variables appearing to the first power, should be in the middle. So all I'm going to do is rearrange this. I'm going to move my 24y squared to the end, putting my 11xy in the middle. So what I end up with is x squared as my leading term, plus 11xy, plus 24y squared. Now I have a squared variable on the front and on the end, and the variables appear together in the middle, each to the power of 1. From here, I use my diamond, multiply my leading coefficient, here it is a 1, by the coefficient of my last term. This 24 goes on top of my x, and the coefficient of my middle term, which is positive 11, goes on the bottom. My two terms that add to 11 and multiply to 24 are positive 8 and positive 3. So I rewrite my 11xy in the middle as positive 8xy plus 3xy, just as we've done in the previous slides. I still have the 1x squared on the front and the positive 24y squared on the end. Taking out the greatest common factor of the left, I factor out an x, leaving me with x plus 8y. And on the right, I factor out a positive 3y, leaving me with x plus 8y. I see x plus 8y repeated, so I factor that out. And I'm left with x plus 3y in the second parentheses. Since both of these factors are prime, this is the final factored form of my original polynomial. Go ahead and try the next three on your own. Be sure to rearrange the terms first so they are in the correct order. Also remember that your leading coefficient must always be positive. For the first, since my negative 6y was in front and my leading coefficient cannot be negative, I put that on the end and moved my negative 5y to the middle, putting my positive x squared in front. Rearranging my terms this way leaves me with a positive leading coefficient. I still have a squared variable in front and on the end, and in the middle I have both variables together raised to the first power. When I factored, I have two prime factors of x minus 6y and x plus 1y. Down to the left, I rearranged my terms by switching my negative 40y squared and negative 6xy. That left me with two squared variables on the ends and the two variables together to the first power in the middle. My two prime factors after factoring are x minus 10y and x plus 4y. Last, I rearranged by moving my x squared to the front and my 9xy to the middle. After factoring, I was left with x plus 7y and x plus 2y. That's all I have for you today. Thanks so much for watching and enjoy the rest of your day.